Those of you that do not know me, my name is Dennis Burgess with Link Technologies. We do consulting. We're a MikroTik master distributor, all that kind of good stuff. But today we're going to be talking about basically network security and mitigation of denial of service attacks. Now, I sit there and say network security because we actually like network security. We're going to talk about mitigating denial of service attacks, but then we're also going to go into several other things. One of those is client isolation. For many wireless networks, people do not do client isolation, and that actually adds a lot of overhead, a lot of variables in your network that you have to help maintain. So we're going to talk about client isolation, and then we're going to talk about network security. This is a high-level overview. We're going to talk about ports, common ports that we block ingress. Sometimes we block them, sometimes we don't. It really comes down to both a technical decision as well as a business decision in those cases. So we're going to talk about that as well. I know I don't have a whole lot of time, so I'm hopefully going to fly through our presentation, and then we will have questions and answers if we have questions afterwards. So what are the common types of denial of service attacks? The most common that I see today is DNS amplification attacks. And the reason why we see a lot of these is that there are open resolvers all over the place. So for those of you that don't know, if you click the little checkbox in Router OS that says allow remote requests under IP DNS, and you do not have any type of firewall on your router, it is now an open DNS server, and it can participate in a DNS amplification attack. Other types of attacks are NTP amplification. This is if you have an open NTP server. Again, this is something that is not as common. There are other types of attacks, just UDP flooding attacks, things like that, but these are the ones that we're really going to focus on today. So how does a DNS amplification attack work? Typically, we have to have the open resolver, of course, but what actually happens is you have a DNS client that is a non-authoritative answer, so it's a DNS open server. And let's say I make a request to my open server, and I request Microsoft.com. Well, Microsoft.com actually uses DNSSEC, so my 56 or 64K packet of requesting Microsoft.com, that server goes out, gets the answer from an authoritative server, and then sends that answer back to me. However, Microsoft.com, that's almost a full packet frame. It's almost a full 1,500 byte frame back to me, just because of all the DNSSEC information. So when we look at that, we get a really, really good amplification. So I send a 56 byte packet out, and I'm almost getting a 1,500 byte packet back. Now, an open resolver, like a MikroTik open resolver, works very well. But how does an attacker actually use it? Well, what they do is they use a botnet. They use a collection of devices and workstations that they have taken control over. Now, I want to make sure I make it very clear here that this is not, I'm sitting on my workstation and my mouse moves. Okay, this is a background application that's running on your computer, or it could be a internet device of things or something like that. It could be a connected cell modem. It could be anything. But that device has a botnet running on it, and a hacker or an attacker will command that to send DNS requests out. But what it does is it spoofs the IP. So the attackee, so the person who's being attacked, what you're saying is, hey, I want Microsoft.com, but I want it to go to this IP, and I'm spoofing that IP address. That's it. Now you have several thousand botnet users running. They're all requesting various DNS applications or various DNS queries, and all these open resolvers are responding to those and sending the response to one IP. That is basically how a DNS amplification attack happens. You can get many, many times of amplification with that. So it does not require many botnets to generate a massive amount of traffic as well as a massive amount of packets. Now, what is the goal for DDoS? Well, typically, of course, it's to take services offline. The number one reason why services go offline due to DDoS is because it fills the pipe going to that IP. So if you are a ISP and you have a 100 meg internet connection and you get a 200 meg denial of service attack, so it's all UDP data coming in, you are out of options. You have to take that data because you have no way to block the data before it gets to your 200 meg pipe. So because of that, now your internet service or your servers, whatever that may be, is offline, or it's very, very, very slow. All right. No bandwidth for real-world applications. You get high latency. The bigger reason that I see most of our denial of service attacks nowadays is online gaming. How many people have online gamers on their networks in here? All right. I had a customer call us up, and they had issues with getting denial of service attacks. Their current consultant could not help them. They asked us to help out. So we helped them out, and it came down to a person who was playing League of Legends. How many people play League of Legends in here? Yeah, we don't like you. This person playing League of Legends, I mean, they have tournaments all the time. Everything from $1,000 to $100,000 are up for grabs on these things. I mean, absolutely insane. And if a hacker can spend $20 on a denial of service attack to attack somebody that they're playing, maxes out their connection, which then kicks them offline or brings up their latency so much that they lose the game, guess what? They have a $10,000 or a $20,000 or a $50,000 prize at the end of the day. I see absolutely tons of gamers that are playing games getting attacked. It's just the way it is. I'm picking on League of Legends, but there are other games out there as well. I also had another customer that they had a daughter that was doing Snapchat, and she said something to the wrong person, and then they were constantly bringing down a network with tens of thousands of customers because of that. So every time she would come online, they would get attacked. So how large are your denial of service attacks? I'm going to tell you right now that you typically need at least one 10 gig link to sustain it. I have seen, matter of fact, I was supposed to put that in the slides, but I have seen attacks, and I've heard of attacks being in multiple hundreds of terabits range. Okay, you got GoDaddy. They suffered a DNS attack that was many, many, many terabits of data. But most of your online gamers, most of your routine denial of service attacks are going to be under 10 gig. Usually we see them between, say, 3 gig and maybe 8 gig. We typically don't see them over 10 gig. However, I have seen them over 10 gig. So if you have to have bandwidth, or let me phrase this, you must have bandwidth to sustain the attack. So I'm going to show you this. This is actually a dude chart. This customer had a 3 gig internet connection, and they were doing, what, about 1.5 gigs of data. They had a 3 gig internet connection, and their ISP limited them on a 10 gig port to 3,400 meg. And right here, as you can see, the spikes there, they hit their spike, and then immediately their traffic goes offline. Their BGP session goes offline because there's no more bandwidth available to even keep the BGP session open. Now, how can you stop this? So let's just say the very first thing you have to have is you have to have enough bandwidth to weather the attack. So if you have a 5 gig attack, you need at least 5 gig of bandwidth. Actually, you probably need a little bit more because you're probably moving data through that. Number 2 you have is what we call black hole servers. Now, this is a BGP concept. Basically, what happens is you advertise. So let's say you have a /21 of IP space. You advertise a single /32 out to a black hole server. Now, it could be a black hole community string. It depends on the ISP. AT&T uses black hole community strings. Cogent has black hole servers, etc. What the black hole server does is it immediately sends out that IP and puts it into a black hole status. So in other words, as soon as it hits, let's say if I'm using Cogent and I send an IP into black hole status, now that IP, when it enters Cogent's network, no matter where at on the planet, it immediately gets dropped. Now that stops my denial of service attack if I'm being attacked. However, there's a downside to black holes. It takes the customer IP offline. effectively because you are black holing it. It stops the traffic from coming in, which then allows your normal traffic to run. But if you run an ISP that you do NAT, which how many people do NAT in here? Quite a few. Black holing the IP that, let's say, a building of 1,000 customers are on, kind of sucks to do. So in that particular case, again, we go back up to the first line of defense. You have to have enough bandwidth to sustain the attack. Another option here is what we call BCP 38. And BCP 38 is best control practices. But basically what it says is it prevents spoof packets from exiting your network. Now, what does that do? That allows, or that prevents, your network from being used to spoof an attack. So if you have 80 computers on your ISP and those have bots running on them, they cannot spoof packets out to send to attackers. Now, the general consensus is that if everybody did BCP 38, there would be no such thing as a DNS amplification attack because it requires someone to send spoof packets. All right, so you could do that. You can also use the RP filter, or reverse path filter. You can set that to strict. That is only if you have a single ingress point. So if you have a BGP router with 2 BGP peers, 2 10 gig links, and that is the only way in and out of your network, then you can set your reverse filter as strict, which basically means you must see the data coming from and to that IP. The easiest way is just to add a rule into your filters that says if you're going out one of your internet rules or your internet interfaces and you're not coming from one of my public IPs, drop the data. That's the easiest way. We do that quite a bit. So, again, you have to have enough bandwidth. What do you do if you have enough bandwidth? Well, the very first thing you have to do is you have to be able to detect how many packets or how the client is being attacked. Now, I am going to show you here in a slide or two a slide of a denial attack prevention firewall. I am going to tell you that that is not going to work for probably half the people in this room. I sit there and build my firewalls based on the customer traffic that is there. I have one customer that they sell 50 meg packages, and a 10,000 per second rule is probably a pretty good rule for us. All right, I have another customer that sells 1 gig packages on NATed IPs. So, 50,000 or 100,000 packets per second is easily plausible. So you have to really think about how your packets work. Normally what we do, though, is we detect our source IPs. These are our attacking IPs. And then we simply block them for about 10 minutes. So the data comes into your router and gets dropped for about 10 minutes. If they continue on the attack, they go right back on that list, and they're blocked for another 10 minutes. The CCRs, the 1036 and especially the 1072, can definitely handle a up to 10 gig denial of service attack. They do have enough horsepower to do so. However, that means you have to sacrifice. You cannot put queues on it. You cannot do a whole bunch of other stuff that MikroTik is really known for about doing AD things inside one router. So you really have to dedicate the router to stopping that denial of service attack. I kind of talked about black hole servers. This is the slide. I kind of already spoke about that. Again, typically with black holes, you are advertising your IPs out. So it's very important that whenever you black hole an IP, it may stop the denial of service attack, but that IP is basically offline. So it's just important to note, again, if you have a single customer that's using that IP, then blocking it to keep the rest of your network running is probably fine. But if you're natting, blocking 1,000 customers is probably a bad thing. The very last thing is that let's say you do not have enough bandwidth. Let's say you have a gig circuit and you're getting more than a gig bandwidth and you do not have black hole server set up. The only last thing you can do is you can call your upstream. I have done this with Cogent. I have said, hey, I have a UDP attacker attacking us at 500 megabit. We have a gig circuit, and here's their IP. Because I can see that IP. I can see my data coming in, but it's maxing out my pipe. They will take a statement. They will typically help you out, and then they block it. They black hole that IP. However, it really depends on your upstream. I'm going to tell you right now, we use Cogent and AT&T. I absolutely cannot stand AT&T because their customer service is basically non-existent. It takes 10 days to add BGP6 onto a circuit. That's after 30 days of the sales order. So that's up to you. You have to make sure that your providers are willing to black hole, that they have black hole community strings, or they have black hole servers. And then if you do not have that, you have to have all that set up prior to a denial of service attack. So make sure you call up your ISP and say, hey, we're doing BGP with you. Do you have a BGP guide? That's probably the easiest way. Most major providers will have a BGP guide, and they'll have, here's the black hole servers. Here's maybe a black hole community string that you can use. So as I said, prevention and getting metrics is really, really important. So this particular script basically says we block port 4444 and NetBIOS inbound. So this is a chain that we jump to from any data coming from inbound. And then we return anything that is under 10,000 per second per destination IP. Now this works really well for several customers of mine. However, I have other customers that this would immediately trigger a crap ton of IPs getting firewalled because of that. So I will sit there and tell you is that if you take this rule and you put it in there and it doesn't work, you do not have to block the data right away. So what this is doing is adding our source and destination IPs to address lists. I usually add a attacker to an address list, say for 12 hours, but I actually don't do anything with that IP. And that is so that whenever I wake up in the morning, I can sit there and go, hey, we've had a denial of service attack, and here's the IP that it was. I also add another destination to my my DOSer to my IP list, and that's my block. That's my 10-minute block. So I actually add it twice to two different lists. Very important because that gives you some ability to look at what actually occurred or what actually happened. Sometimes you cannot use IPs by destination. Again, if you have multiple 1 gig clients coming off one IP, that's very easy. A 10 meg connection downloading is 1,000 packets per second. Do the math at a gig. It's a lot of IP packets very quickly. So you need to make sure you have your levels set correctly. Again, this is, you do not have to block. You need to make sure you know what you're going to block beforehand. Right now I'm with a customer that we're working on their blocking lists. It's we have not found good numbers yet, but we're not blocking anything. All we're doing is adding. And then I come back the next morning and they go, okay, we had a denial of service attack. It lasted 10 minutes. We went down. Okay, let's look at your list. Well, you got 500,000 IPs in your list. I'm assuming that that is not a valid DNS attack. In other words, most of the time you may have 100 or 200 IPs, but you're not going to have 500,000 of them. So our levels are too low. We have to crank up our levels to make sure that we get only that denial of service attack. And it should be pretty easy to do. You just have to find that right level. Alrighty, any questions about basic denial of service attack prevention? Awesome. So now we're going to go into client isolation here. In my ISPs and my customers, we do client isolation. In MikroTik, if you're using MikroTik as wireless APs, you have that default forward option. You can uncheck that. That will isolate each wireless client. But what if you have 5 or 6 or 7 APs connected to a CRS? Well, most of the time, we would sit there and bridge those together, but then we use bridge filters. Or we use our split horizon. So we have a horizon there. And by simply putting all the IPs or all the APs in their interfaces into a horizon group, that allows you to block same horizon traffic. So I can get I have two VLANs there, northeast and southeast, and they're on the same horizon. So they cannot talk to each other. That effectively isolates my clients. Now, there's other ways of doing this. You can also use bridge filters. So you can go to your bridge filter. You can create a bridge filter rule, chain forward, action drop. That drops everything going from one port to another. So again, this is very easy to do. Now let's say you do have a client that needs to talk to another client. Well, you can, if you're using the bridge filters, which is the software-based method, you can add maybe one of their MACs and say, hey, if you're trying to get to this MAC address, allow it, and put that above your drop rule. So that's another way to do that as well. How many people have rogue DHCP server issues? If you do this, you will never have a rogue DHCP server because they can only see one ARP entry. The client should only be able to see one ARP entry, and that ARP entry is of your router. Okay? So if you have rogue DHCP servers, if you do client isolation, you can do that. Something else to note is we do have a DHCP Alert feature. So if you use DHCP servers and you have rogue DHCP operations, there is a DHCP Alert tab in the DHCP server. And what that'll do is that will actually give you a MAC address and the IP address of the router that's trying to be a DHCP server on your network that's not valid. So that is really good. But again, if you have proper client isolation, you should not have any rogue DHCP servers out there. Now, if you're using switches, most of your managed switches, not unmanaged, but most of your managed switches have a feature called protected port. And protected port is basically the same thing. It is client isolation. So any ports that are in the protected port status, they would not be able to talk to each other. On most of your switches, or most of the switches that I use anyway, they're basically, it's a on or nothing thing. So either you have protected port status on or you don't. Whereas a lot of times I like to bring VLANs back from my switch. I VLAN my switch out, and then I sit there and put all my VLANs into a bridge group called customers, and then I put my split horizons on there to effectively give me more control over that switch group if needed. These are really, really good ways to keep your clients isolated and keep rogue DHCP servers from occurring. It also prevents unnecessary traffic. So if you are getting ARPs and you're getting broadcast traffic, etc., it keeps all that. Basically, the only thing your end user should be able to see is the IP address of your customer router. Or I'm sorry, your core router. So if you sit there and do an IP scan, let's say you have a /21 that's all bridged together, and if I did an IP scan on it, the only thing I would see is my very first IP, which is my router's IP. Okay? So next, we're going to go into network security. Again, this is a pretty short presentation, but we're going to get into this. Network security really depends on your network and your business case. In our case, we recommend that you block a number of ports inbound for consumers. And the reason for that is consumers are, well, they're dumb. Simple as that. They are not very smart. They buy the cheapest router they can get, and they put it in there, and they expect it just to work. The problem is that how many of those clients turn on NTP servers? How many of those clients turn on open DNS servers, etc.? And they have no idea that they are actually causing damage to the internet at large versus not. So what do? We block many different common ports, both TCP and UDP. These are our port lists. So we block, let's see here, we block port 80, port 443, and this is inbound. It doesn't matter if they have a public IP. If they are on a consumer-grade package, these ports are blocked. We block remote management ports, 8080, 8181, 81 through 90. We block Telnet, SSH, FTP. They don't need to be running an FTP server. They don't need to be running a DNS server. They don't need to be running a NTP server. They are purchasing a consumer-grade account. Again, this is a business decision. It may be good. It may be bad. In our case, it works out because then we get a customer that says, hey, I wish to have remote access to my security camera system. Okay, you have to upgrade to a business package. Well, why? I just want to have remote access. Well, you're running a server, so because of that, now anybody can make a request and open that up, so you have to have a business package. So we change their IP to a IP block that has no firewall on it. We change their port speed, and they're happy as can be. We're getting our money now for that. So these are common ports that I block. 4444 should be up there. That is a a very common virus port and Trojan port. It should also be blocked. What was that? So that is a business decision that we decided to allow a client to do. So 3389 is remote desktop. If you're running remote desktop on 3389, you're going to get hacked eventually. Yeah. But it is what it is. We decided that for the customers that wish to do that, we allow it. But that's usually a low bandwidth application as well. So again, I'm not saying that's right or wrong. I'm just saying that is what we've chosen. There are plenty of ports. Another good one is 1433. Can anybody tell me what that is? Yeah. So if you have you get customers that fire up, they'll install some program that installs MySQL with a default login on a public IP. That's a big, ugly intrusion detection thing there. So we block that as well. Again, most users are not very smart, so that's why we consider doing this for our residential packages. I do know some people that use NAT as a security mechanism. Most security experts say NAT is not a security mechanism, but it can be pretty effective for natting many clients. Something else, Winbox. We block Winbox to our network from external sources. Why? We don't need anybody that's not on our network accessing any of our MikroTiks. If they need to, they can VPN in. Again, this is up to you. It is a up to you and business decision. We use it to help us get more money from our customers because they want to run servers. Also, though, IP services. Many people don't go there and just they leave everything on. Everything should be off besides what you use. Simple as that. That is my opinion. It doesn't matter if you have a firewall blocking it or not. So we typically turn off everything besides 8291 for Winbox. That is typically what we do. We turn off Telnet, we turn off our APIs, we turn off SSH, because, again, the client does not need to be logging into their router. They don't know the password anyway, but you never know, they may try. They don't need to see a web interface, etc. So forwarding inside of your network. This is actually a thing that's recently came up. Typically, you consider your network a more trusted or more secure than the public internet. Of course, anything has to be more secure than China, right? I mean, with all the attacks we get. But the ideal is that attacks can come from anywhere, and you may need to build your DDoS rules on a per-site basis to prevent a inside device from DDoSing your devices. So it's really up to you on building that, but you need to make sure that you think about it. Do you trust your users enough to have Winbox access or have the ability to open your management IPs? How many people here use in-band management? Nobody's going to cough up to that one. But most people do not separate their management network and their data network. They don't have a separate platform. They don't have separate radios, etc., which is perfectly fine. I don't sit there and think that you need to do that. However, you need to sit there and say, hey, if you're coming from my customer IPs, you cannot get to my management IPs. You need to make sure that that is all firewalled off as well. And everybody in here runs IPv6, right? All right, everybody needs to be running IPv6, but the big thing here is you also cannot forget about IPv6 and firewalling, because IPv6 is a completely separate platform. It is a completely separate stack on it, so you need to put your own firewalls and duplicate your firewalls for IPv6 as well. So with that said, I have nothing else. Nice and quick and easy. Questions, queries, posers, or other informational tidbits that I can give?
Sorry.
Yeah, we want the internet to hear you.
Great. How many complaints or upgrades do you get from that big inbound block list of ports?
So it really depends. If we have, we had a network with about 500 subs that we implemented that. And within about 2 months, they probably got about 30 upgrades. They probably got about another 30 to 40 people complain about it, but dealt with it. So, you know, if they're smart enough to deal with it, to use a high port number or something like that, hey, let them. But they actually know that they're an open DNS resolver, or they actually have some intelligence behind them if they can do that. That's the way I look at it anyway. But I mean, they did get several network upgrades and upgrades for that. Any other questions?
If you turn off IPv6 on the MikroTik itself, then the firewalls are safe from that. Am I correct in that?
If you turn off so if you turn off the package,
Correct.
then there's no IPv6 running on the router, so
That's
it's not going to
what
do
I thought.
anything. Yep. However, you should be running IPv6.
Yeah, as a side note, we'll be having a default configuration for IPv6 firewall soon. Although it's off by default, the package.
There you go, there you go. All right, any more questions? We got a gentleman up here in the corner. And I apologize if I didn't look over here.
Does IPv6 work with the hotspot?
No.
When will it?
You need to talk to the person standing behind you. In theory, the IPv6 system does not have NAT, which NAT is required for hotspot. However, I do know people that NAT IPv6. So even though it's not really, quote, in the standard-ish stuff, I'm assuming they're going to have IPv6 soon in hotspot. However, there is a really good answer to that. So I'm assuming you're using hotspot to control your users, authenticate users. Yeah. PPOE is the way to go. It gives you a singular radius login, and you can control both bandwidth stack or both stacks simultaneously. So that is my recommendation. Is PPOE is the way to go on that.
Any more questions? Okay, thank you, Dennis.
Thank you very much.